Hi class, problem number 6 on our notes for today also deals with the equation of distance equals the rate multiplied by the time. Distance equals rate times time. So it says this train A, leaves the station going 64 kilometers per hour. 6 hours later, train B leaves the same station traveling in the same direction at 84 kilometers per hour. So obviously train B is going faster, however it leaves later. How long does it take train B to catch up to train A? So what we have here is we have this station obviously, right, with our railroad tracks. And we're going to have train A in red, and we're going to have train B in green. A leaves earlier, and it's traveling at 64 kilometers per hour, and let's just say it ends up right here. Okay? And now, 6 hours later, train B leaves, and it's going faster. It's going 84, so it's going at a faster clip. How long will it take train B to travel this distance until it catches up to train A? As you can see, class, the big thing that I want you to notice with this illustration is how far did A and B go? They went the same distance, didn't they? When train B catches train A, they have traveled the exact same distance. They left the same station, and once the train B catches A, they're going to stop at the same spot. So if they start at the same spot and leave at the same spot, their distances equal each other. So get this. You have train A, where the formula for that is distance equals the rate multiplied by the time. And now you also have train B, where that formula is the distance of train B also equals the rate multiplied by the time. Now, setting up these two equations, what we can do is, because these two distances are equal to each other, we can substitute those variables in for each other using substitution. So if I know this distance equals the rate times the time, I can substitute that in for this distance. All I'm doing is using the property of substitution. If this d and this d are equal to each other, then this rate times time and this rate times time are equal to each other. So that's how we're going to set this one up. Train A, rate multiplied by the time, is going to equal train B's rate times the time. So that's how we're going to solve this one. So let's take a look. Train A, what is train A's rate? Train A leaves the station at 64 kilometers per hour. So its rate is 64. Next thing we know, train B leaves the same station traveling in the same direction at 84 kilometers per hour. So train B's rate is 84 kilometers per hour. All right, here comes another tricky part. Let's see. 6 hours later, train B leaves the same station. So we got to ask ourselves the question, which train travels a longer length of time? They both travel an equal distance, but how about which train travels for a longer time? Let's just say train A leaves at noon, 12 o'clock. 6 hours later, that means train B would leave at 6 o'clock. Right? Now, once they reach their destination, once they go that same distance, they're going to get there at the exact same time because train B is going to catch train A. So that would mean that train A would travel 6 hours further, or it would travel 6 hours more. Let's just say that, well, I don't know, let's say they get there at 12 o'clock the next night. Let's say they get there at midnight. Train A traveled 12 hours, where train B only traveled 6 hours. Train A traveled a longer length of time. So because we don't know what time is, we're going to say train B traveled for X amount of hours. So it's rate times time, it's 84 times X. If train B traveled X amount of time, then A would be that X plus 6 more hours. It traveled 6 more hours than train B traveled as far as time is concerned. So instead of X, it would be X plus 6. And so now all we have to do is solve for X, and we get our answer. We're first going to use the distributive property. 64 times X is 64X, and 64 times 6 is 384. That equals 84 times X, which is 84X. Let's get all our X's to the right. Subtract 64X. 384 equals 20X. Divide both sides by 20. 384 divided by 20. We have an answer of X equals 19.2. X equals 19.2 hours. That's how long it's going to take train B to catch train A. Train A would then travel that 19.2 hours plus 6. So 25.2 hours would be how long train A would travel for. I hope that problem made sense to you. Be sure to let me know if you have any questions on that, and I could illustrate that, maybe using some visuals or write a little bit more on the chalkboard or the whiteboard.